Hello everyone, welcome back to Diksha Karnataka YouTube channel, and in the Chakravyuh series this is a recorded lecture. I don't have enough time to take all the classes live because all the teachers are taking live classes. So in between, whenever I can get some time, I am taking this recorded lecture for a slightly less important chapter, electromagnetic waves, in terms of the PU questions, but in terms of objectives and MCQs, definitely you cannot. As I said, all the chapters are equally important. At least one MCQ will come from all the chapters, and all possible MCQs you have to be ready with. But in my opinion, this is slightly easier chapter. If you go through this lecture, all of your MCQ needs from this chapter will be over. So without any delay, let me start this. I will not take too much time today. I will try to close this lecture as quickly as possible. So let's start. So first is displacement current is produced due to a constant electric field, constant magnetic field, changing electric field, changing magnetic field. And while this lecture is running, you can mention in the live chat comment below. Okay, in case I am watching, I will definitely be like to help you out from wherever I am. So this is changing electric field. Displacement current is produced by a changing electric field. Obviously that is the main purpose, right? So displacement current is given by epsilon naught d phi e by dt. That is, electric flask is changing. Electric flask changing means electric field will definitely change, right? Now let's move on to the next question. The expression for displacement current. I have already given you this answer in the previous question. So expression for displacement current is mu naught d phi e by dt. No, not option D, option C. And be careful about this option. Okay, this mu naught is coming from Ampere's circuital law and not from the expression for displacement current. Okay, so some students often confuse between this and this. I know this is not correct. That was exaggerated. But this, between this and this is the answer, because obviously this mu naught is coming from Ampere's circuital law. Let's move on to the electromagnetic wave theory. Was proposed by Michael Faraday, Louis de Broglie, J.C. Maxwell, Albert Einstein. It is James Clerk Maxwell, not Glenn Maxwell. Okay, if I was a teacher, I would have given Glenn Maxwell, and I know many students would answer. Okay, at least 10% of the students, maybe not you guys. You guys are watching my lectures regularly, but some other students will definitely answer this question. Okay, now choose the false statement. So very interesting, we have to choose the false statement. Electromagnetic waves are produced by accelerated charge particle. Correct statement. For electromagnetic waves, E naught by B naught is C, where E naught and B naught are electric and magnetic field amplitudes. Yes, that is also correct. Electromagnetic waves are transverse in nature. That is also correct. Electromagnetic waves can be deflected by electric field and magnetic field, which is not correct. Electric field and magnetic field cannot deflect electromagnetic wave, even though electric and magnetic field, they are producing electromagnetic wave, but they cannot directly deflected by electric and magnetic field. Okay, they will pass through. That is why gamma rays, for example, is one of the example of electromagnetic waves. They do not deflect by any electric or magnetic field. They pass straight. Very interesting, right? So even though they are produced by electric and magnetic field, they do not get deflected by electric and magnetic field. Next question, an electromagnetic wave was going through vacuum is described by E is equal to E naught sine kx omega t and B equals to B naught sine kx minus omega t. Then E naught B naught equals to omega k, E naught omega is equal to B naught k, E naught k equals to B naught omega, E naught by B naught equals to omega k. Let's see. So first of all, we know that E naught by B naught equals to what? C, right? E naught by B naught is equals to C, and C equals to omega by K. Okay, that is also another equation that you should remember. So now put that E naught by B naught equals to omega by K. So now do the cross multiplication. K E naught equals to omega B naught. Okay, so K E naught equals to omega B naught. So correct answer is option C. Okay, This is one of the trickiest question of the all questions that I have selected for today. Other questions are slightly straightforward. Let's see. Out of the following options, which one can be used to produce a propagating electromagnetic wave? A chargeless particle, an accelerating charge, a charge moving at constant velocity, a stationary charge. Only accelerating charge can produce electromagnetic wave. Steady charges or static charges or chargeless particle definitely cannot produce electromagnetic wave. Which of the electromagnetic wave used in long range communication? So in long range communication, definitely radio waves are used, not microwaves, not infrared, definitely not gamma rays. So it is only radio waves are used. Next, the increasing order of wavelength of infrared, microwave, ultraviolet and gamma rays is. So increasing order of wavelength, that means we will start with smallest possible wavelength and slowly we will go towards the highest possible wavelength. Now out of this, gamma rays have the smallest wavelength and infrared, microwave, ultraviolet. Microwave has the highest wavelength. Okay, infrared and ultraviolet are in between them. So let's see which one is satisfying our condition. So out of all the options, only this one starts with gamma rays. So after gamma ray, ultraviolet comes, next is infrared, then we have microwave. So this is the correct answer. So be careful, it is said increasing order of wavelength. Increasing order means starting from small going towards the highest. So slowly it will increase. From gamma to ultraviolet, wavelength increases. Ultraviolet to infrared, wavelength increases by more. Then infrared to microwave, again wavelength increases. Now if the same question was asked in the increasing order of frequency, then it will be just opposite to that. Okay, so the correct answer would be the option A. Frequency, in terms of frequency, gamma ray has the highest frequency and microwave would have the lowest frequency out of these four given waves. The ultraviolet region of the electromagnetic wave spectrum lies between X-ray and visible region, gamma ray region and X-ray region, visible region and microwave region, infrared region and radio wave region. So if you remember that ultraviolet is basically frequency which is more than that of violet. Violet is in the visible region. So basically ultraviolet comes sandwiched between visible and X-ray. Okay, so it is basically sandwiched between X-ray and visible region, that is the answer. Okay, infrared on the other hand is sandwiched between visible and microwave. Okay, visible and microwave, infrared ray is sandwiched between, right? Next, move on. The wavelength range of X-rays, you have to remember this answer a little bit. Okay, either you can remember the spectrum diagram or you can remember it. So wavelength range for X-ray is about 10 nanometer to 10 to the power of -4 nanometer. It is given in your NCERT book. You can check that out. The electromagnetic waves suitable for radar systems used in aircraft navigations are. So what is the wavelength that we use in the radar system? So radar is basically where, suppose there is a plane flying at some height and you want to determine how high the flight is or what is the exact location of the flight. So that is called radar. And if you may have seen in movies also, they show some circular system like this. They have like this kind of system, and suddenly there was some line rotating like this, and suddenly there is a blue dot appears. That means some enemy is coming, some torpedo is coming, or some enemy ship is coming towards it. If it is in air, then that signifies some unknown ship is coming. If it is in under the water, then that signifies some enemy ship or torpedo is coming. Okay, even though the frequency is slightly different for sonar and radar, but again this is in underwater we use sonar, in space we use radar, and radar uses radio waves. Okay, high frequency radio waves, short wavelength radio waves, whatever you can say, the top part of the radio wave is used. Next is statement 1. Displacement current goes through the gap between the plates of a capacitor when the charge on the plates of the capacitor does not change. No, It is only when the charge is changing, that means when the capacitor is in the charging state. So displacement current passes through the plates of the capacitor only when the capacitor is charging. If it does not change, then no displacement current in the entire circuit will be 0. Statement 2, the displacement current arises in the region in which the electric field is constant with time. No, again wrong. Electric field must vary. So both statements are wrong. Both statements are incorrect. If they said that the capacitor plate is changing, okay, and its field is changing, then definitely this would be the reason, this would be the cause, right? So they would have some relationship, but here both are opposite. Both opposite means both statements are wrong. Okay, so this kind of questions may also come. Statement 1, electromagnetic waves are transverse in nature. Correct. The electric and magnetic fields in the electromagnetic waves are perpendicular to each other and the direction of propagation. Okay, so that means if suppose this is the electromagnetic wave, EM wave, and electric field and magnetic field, they are also perpendicular to each other. So this is EX, this is BY, this is EM wave, that is along the Z axis. Obviously we know that electric field and magnetic field are perpendicular, and electromagnetic wave is mutually perpendicular to both of them. So that is why electromagnetic waves are transverse in nature, because they are vibrating perpendicular to the direction of motion. Both of them who are responsible for the production, both are vibrating in the perpendicular direction. So statement 1 and statement 2 are correct, and statement 2 is the correct explanation of statement 1. Another statement based question, the velocity of electromagnetic waves depends on the electric and magnetic properties of the medium. Okay, the velocity of the electromagnetic waves in free space is constant. Okay, so we know that speed of electromagnetic waves is basically square root of mu epsilon. Okay, and in free space it is basically 1 by mu naught epsilon naught. Now mu naught and epsilon naught are constant, so definitely C is constant. For any other medium, mu and epsilon depends on their respective magnetic and electric properties. Okay, based on how well magnetic property it has, mu can vary from medium to medium. Similarly, epsilon can vary from medium to medium. So both statements are true, even though there is no apparent relationship between these two, right? Second statement does not explain the first statement. So both statements are correct, but statement 2 is not the correct explanation of the statement 1. Okay, if they have given this formula perhaps in the statement 2, then you could have said yes, correct explanation. But this is just both of them are just statements without any link, so they are correct but no explanation. Now another statement based question, infrared radiation plays an important role in maintaining the average temperature of Earth. Infrared radiations are sometimes referred to as heat waves. So as you know that during the day Earth receives sunlight, and at night it radiates the energy. Okay, it radiates the energy, so that is basically in the form of heat. Now this is the infrared radiation. Okay, so basically what is happening, during the day Earth receives heat from the sun, and at night it radiates the infrared radiation. That is how the temperature of on the surface of the Earth is controlled, right? Now infrared radiation are sometimes referred to as heat waves. Even though that is correct statement, I personally do not feel that this is correct explanation. Okay, heat wave can be anything. Okay, only thing that can we have said that at night Earth radiates infrared rays back to the space. That could be the possible explanation for the statement 1. Even though this is a correct statement, heat waves, basically heat, whenever we say this is heat is transmitting, heat is basically means that infrared radiation. Whenever suppose we know that heat transmit in 3 different ways: conduction, convection and radiation. The radiation part of the heat is basically infrared ray. Okay, during the winters you do a bonfire, you have put up some wood and put a fire near it, then when you are doing like this, this is very good in the weather, that is basically you are receiving infrared rays. Okay, so both statements are correct in my what I think is both statements are correct, and statement 2 is not correct explanation, even though you might think that heat waves actually explaining that why it is maintaining the average temperature. My opinion is that average temperature has nothing to do with this explanation. The explanation has to be slightly better than this. Okay, you cannot simply say that because it is heat wave it can control the temperature. Now question number 16, microwaves are used in microwave ovens. Obviously the frequency of microwaves are matched with the resonant frequency of water molecules. Yes, that is also correct. So and that is the correct statement. Now here you have to remember that microwave ovens basically heat up the food. How does it heat up the food? It heats up by heating the water present inside the microwave. So if you put something which has some water in it, and if you keep it inside the microwave oven, okay, the microwaves will heat up the water present in the food, and slowly that heat will be transferred to other food particles as well. So basically this is the correct statement, and this is how microwave functions. So it is the correct explanation. This is the basically function of microwave. Okay, now let's move on to the next question. Speed of light according to Maxwell's equation, C is equal to 1 by mu naught epsilon naught. Easy question, no waste of time. Next question, the angle between electric field and the magnetic field in an electromagnetic wave. Electric field and magnetic field, they are always mutually perpendicular, and this is also mutually perpendicular to the propagation of wave. So basically 90 degree is the answer. Another easy question without wasting time. Question number 19, I hope. According to the generalized Ampere-Maxwell law, B dot dl, closed loop integral B dot dl is equal to mu naught IC plus epsilon naught mu naught d phi E by dt. I think this is from one of your previous year questions. So be careful, you have to answer this question. Now next question. Electromagnetic waves used in the treatment of cancer is X-rays. X-rays are used in the cancer treatment of cancer. Next question, which of the following ray is absorbed by ozone layer? We already know UV ray. UV ray is absorbed by ozone layer. Which of the following ray is produced by hot objects? So we already explained multiple times, infrared rays. Okay. Next question, which waves are used for mobile communication? Again, radio waves are used for mobile communication, not microwave. Which will produce electromagnetic wave? Accelerated charge, moving charge, magnets, static charge and a static magnet, a static charge, accelerated charge. Similar question but slightly language difference. The experimental demonstration of electromagnetic wave was done by Maxwell, Hertz, Marconi, Bell. This is an interesting question. This is slightly related to history of electromagnetic waves. Now you have to be careful. Maxwell is someone who gave the theory, experimentally proven by Hertz, Heinrich Hertz. Okay. The ultraviolet region of the electromagnetic spectrum lies between the ultraviolet. This one I think it is repeated. Obviously it is X-ray and visible region. We already explained it and answered it. Next question. The expression for displacement current ID, again same question with different few different options. So again ID is mu naught d phi E by dt. No, ID is this. Okay, somehow this value is missed here. This will go here. Epsilon naught d phi E by dt. Okay. Electromagnetic waves suitable for radar system used in aircraft navigation are now in this case they have not given you radio waves. If you see, the same question came. Now here they have given gamma rays, ultraviolet rays, infrared rays and microwaves. Now obviously gamma rays, ultraviolet ray and infrared rays are not used. Only closest possible answer is microwaves. Okay, even though the correct answer is radio waves, but in this question this is taken from one of your question papers and they have given this exact option. So if the same question comes in your exam, you have to choose microwaves. X-rays, microwaves and gamma rays traveling in vacuum have same velocities but different wavelength, same wavelength but different velocity, same velocity and same frequency and different frequency. I don't understand the same frequency and different frequency. I think same frequency but different velocity, I think they tried to say. Okay, yes. Now which one is correct? Now we know that all the rays have different wavelength and different frequencies. Okay, even though in vacuum all types of rays, they do travel with same velocity, that is speed of light. We say speed of light. Speed of light does not mean that only of the visible light, only of the Vip gear, okay, red, yellow, indigo, violet. No, all lights, including the lights that we cannot see, infrared, UV, X-ray, okay, gamma ray, they all travel with the same speed, but their corresponding frequencies and wavelengths are different. Okay, gamma ray has smallest wavelength, highest frequency. Radio waves have highest wavelength, smallest frequency. Okay, so the answer is same velocity but different wavelength, or same velocity but different frequency. Okay, so that combination is fortunately not given here. Okay, so same wavelength but different velocity, obviously not correct. Different velocity is not possible. Same velocity but same frequency, that is also not correct. If it was given different frequency, that would have been a correct option. Same frequency and different velocity, frequency is different, velocity is also same, so both are correct. So only option A is correct answer for this question. Now next question, the electromagnetic waves with the lowest frequency among the following are. Lowest frequency, very careful, gamma rays, UV rays, microwaves, radio waves. So as I said in a previous question, gamma ray is the lowest frequency, right? Just checking if you are listening or not. Gamma ray has the highest frequency, lowest wavelength. Okay, UV ray is somewhere in between. Microwaves have a higher wavelength compared to gamma rays, but in this case the winner is radio waves. Radio waves has the lowest frequency, highest wavelength. Last question of today's class, the frequency. So this is a smaller class because most of the questions are mostly memory based without any calculations. Okay, in the entire thing we have done only one calculation, that was very simple, E0 by B01. Otherwise this is a very short and crisp chapter, so that is why I chose this chapter. Is perfect for offline recording. So the frequency of X-rays, gamma rays and UV rays are A, B, C respectively. So frequency of X-ray, let's write it down one by one. X-ray is A, gamma ray is B, and UV rays C. Now which, see, this is all frequency nu, this is gamma. Okay, gamma has a loop in the leg. Okay, this is gamma, this is frequency. Though they are, even though they are look like same, they are not same. Okay, so now frequency is ABC. Which one has the highest frequency? I mentioned multiple times, gamma ray has the highest frequency. So B should be the big brother. B should be the bigger than everything else. Now X-ray is just after gamma, so it will have bigger frequency, higher frequency compared to UV ray. So it will be slightly less than A, but it should be greater than that of C. Okay, so B greater than A, greater than C. So B greater than A, greater than C. This is slightly logical question. So we have closed this lecture quickly, and I hope you enjoyed this offline, not so interactive Chakravyuh series. If you have any doubts, any questions, mention in the main comment section below. I will try to answer all of your queries, and I will see you on Monday with live session for Chakravyuh. The chapter will be announced in our WhatsApp channel, so don't forget to join our WhatsApp channel. Till then, bye.